Hi ladies and gentlemen, we're going to be working on a little bit more review of our Algebra 1 skills and maybe some pre-algebra skills as well. What I'm going to do is lead you through part A, 1A, and then I'd like for you to graph and label points B, C, and D, and then label the quadrants. If you don't remember, don't worry, when you turn the video back on, I'll lead you through a little bit of the labeling of the quadrants. For right now, let's take a look. We know that when we are graphing point A, we have an x-coordinate and a y-coordinate, and those pertain to our axes. The x-axis, I should say, is horizontal, and the y-axis is vertical. In addition, we have a negative direction for x and a positive direction for x, a negative direction for y, and a positive direction for y. And hopefully, that will remind you that when we're labeling point A, we're going to start at the origin where we see the 0. We're going to go 1 coordinate to the right and 3 up. So 1 and then 1, 2, 3. I'm going to mark this as point A. Okay, so now I'd like you to pause the video, do B, C, and D, and then turn it back and label the quadrants and then turn it back on so that you can check your work. Hopefully you were able to successfully and easily locate and label points B, C, and D. Now we're going to go for the labeling of the quadrants, and they are 1, 2, 3, and 4. And sometimes it's hard to remember exactly how to label them for some students. So knowing that quadrant starts with a Q, but the sound is kind of like a C sound, and that is the order in which we label these quadrants. So 1, 2, 3, and 4, we go counterclockwise, we form a C, and maybe that's a little bit of a helpful reminder to how to label the quadrants in the future. A skill that's not going away, by the way. So what I'd like for you to do is pause the video now, and I'd like you to finish the rest of this page, questions 2, 3, and 4. When we turn the video back on, we'll discuss them briefly. Taking a look at number 2, we see the word sum, and we want an expression that represents the sum of a number x and the number 11. Sum means add, and we use that as the operator between x and 11. Just as a reminder, if we had seen the word difference, it would be a minus sign. If we had seen the word product, that would be a times sign. And if we had seen the word quotient, the quotient of two numbers, that would be a division between those two numbers. Taking a look now at number 3, I've done something that hopefully you do most of the time, and we especially want to do when we're doing word problems. We've defined our variables C and M. Now the reason that we do that, most importantly, is because we want to be able to remember what each of those variables stands for when we finally put the equation together. And in this case, we had Angelica starting out with 15 comic books, and then each month she buys 3 more. When she buys 3 more comic books per month, we know that that's a rate of change or a slope, and that's going to be 3 times M, which is the number of months that have gone by. So when we write the equation representing the number of comic book C that Angelica has at the end of each month M, we write that as C equals 15, her starting amount, plus 3 times the number of months that have gone by. So we can plug in the number of months that have gone by and determine how many comic books Angelica has. As for number 4A and B, you needed to plug in, and once you plugged in, you just needed to follow order of operations to get the correct answer. The work is shown here in detail, starting out with proper substitution. That's how you always want to start out your work. Plug in, showing the line of proper substitution, and then most of the time we can show the math, but sometimes we might be able to do some of it mentally. And we always want to follow order of operations, of course, to make sure that we come up with the correct answer. So that's it for page 1. We're going to move on to page 2 now. Chances are very good that you're going to be super comfortable with questions 5 and 6, with possibly the exception of 6D. So go ahead and get started on these. or I should say, pause the video, get started on those, and then if you are unsure about 6D, we'll go through that one together. The other ones, you'll just be checking your answers when you turn the video back on, so see you back in a minute. Hopefully you were very comfortable with 5A and B and 6A, B, and C. So check your answers now. For 6D, you might have felt a little bit uncomfortable, but we're probably able to move the 6 to the other side by adding 6 to both sides. The next step, of course, would be to get rid of the 4. And we know that D over 4 is the same thing as 1/4 times D. What this means is we need to get rid of the coefficient of the D, which is 1/4. And normally we would divide both sides by the coefficient, but in this case, because it's a fraction, what we're actually going to do is we are going to multiply by the reciprocal. So we multiply by the reciprocal of 1/4, which is 4, on both sides of the equation, and that brings us to a final answer of D is equal to -12. And once again, hopefully you felt pretty comfortable with all of these. If you have any questions about any of these problems, bring them to class and or extra help. And let's move on to number 7. Number 7, A and B, we are being asked to solve and graph the inequalities. So just a little reminder, we're graphing those inequalities on a number line. So go ahead and work on those. Also work on number 8, where we're simplifying the fractions. We'll check answers in a minute when you turn the video back on. So turn the video off now and get started on 7 and 8. All right, so question number 7A is relatively straightforward. We know that we need to get rid of the coefficient of the variable, so we need to divide out the 3 on both sides, and that gives us G is greater than 6. We remember that when we're graphing on a number line, the greater than symbol, if we have the variable on the left-hand side, then the greater than or the less than symbol, can be an indicator, can act like an arrow. And so what we can say is we know that there is no or equal to. We're going to leave an open circle. And we are, in fact, let me redo that, leave an open circle. And this is going to point us to the right-hand side. It's all numbers G that are greater than 6. Greater than is on the right-hand side. And the arrows match. We can see that the arrow and the arrow match on those. So when we get to 7B, it's a tiny bit more complicated because we are dividing, when we get rid of the coefficient -4, we are dividing by a negative number. And anytime we either divide or multiply by a negative number, then we have to reverse the direction of the inequality. So where we started out with -4K is greater than 8. As we divide both sides by -4, we have to reverse the direction of the inequality, and we have K is less than, and after we simplify, we have -2. So once again, we have no or equal to, so we're going to have an open circle, and this one is going to point to the left-hand side, the less than side. All right, for numbers 8B and A, what we want to do is find the greatest common factor between the numerator and denominator and divide that number out to get the most simplified version of the fraction. And you can see the answers to 8A and B here. If you have questions, again, bring them to class. Now let's move on to page 3. Once again, I'm confident that you're going to find questions 9 and 10 very doable with your pre-algebra and algebra 1 skills. So I'm going to ask you to pause the video, work on both 9 and 10, and then turn the video back on where you can check your answers. Then we'll be working on number 11, A and B together. So turn off the video now. Okay, take a look at the answers. For number 9, A and B, I showed you 2 different ways that you could work on those questions. So again, as always, if you have some questions, definitely bring them into class or to after school or before school for extra help. Let's move on now to number 11, A and B, and these are probably going to come back and your memory will be refreshed relatively quickly. Here we have the square root of 49 times the square root of 100. Both of these numbers are perfect squares, so the square root of 49 is 7, and the square root of 100 is 10. We're going to multiply the two results together, and we end up with 70. The next one is a little bit less straightforward because neither 2 nor 32 are perfect squares. So we are going to have to do a little bit more work here. I'm going to keep the square root of 2 as is, but the square root of 32 I'm going to change. And if we think about, whoops, I kind of gave it away right there, didn't I? So let's think about 32 and breaking that down. We know it's 2 times 16. 2 is the prime factor, but 16 is a perfect square, so we're actually going to stop right there. And we know that this square root of 32 can be rewritten as the square root of 2 times 16, which can be rewritten as the square root of 2 times the square root of 16. So we know square root of 2 times square root of 2 is 2. And square root of 16 is 4, so our final result is going to be 8. And once again, these become easier and easier with a lot of practice, so if you need some practice, definitely come in and we can give you some additional work. Now, on number 12, all we're doing is rounding. In the case of the 10th place, the 4, that first 4 is the 10th place, so we're going to look to the number to the right, and we see that it's a 4. So basically, if we have 0 through 4, we stay, and if we have 5 through 9, we round up. So in this case, we have a 4, so we're going to stay. We're going to round to the 10th place, so 7.4 is our final answer. And for the next one, we're going to round to the 100th place. So this one is the 10ths, this one is the 100ths. We look to the right, one place to the right. It's between that 5 and 9 range, so we're going to round to 9.03 because we're only rounding that one digit. And that's a final answer for 12B. Let's take a look now at page 4. Move on to the next page so that we can work on number 13. And we'll start with number 13. In this case, we have an absolute value. Well, in A and B, we have absolute value equations. And so what we need to do is remember that in absolute value equations, we have two cases. And case 1 is going to be our positive case. Case 2 is going to be our negative case. So in case 1, we're going to take out, oh, by the way, before I go any further, we always want it to be absolute value equals and then a constant if possible. Those are the simplest ones to work with. So in this case, we're going to have x plus 2, which is inside the absolute value for case 1, absolute value bars, is equal to 9. In case 2, we're going to have what's inside the absolute value bars, x plus 12 is equal to, and this is our negative case, so it's going to be equal to negative 9. So we subtract 12 from both sides, and we end up with x is equal to negative 3. On case 2, same thing, we're going to subtract 12 from both sides, and this time we're going to end up with x is equal to negative 21. Now, the next thing that you need to do is, for absolute value, we want to check our work. So that means you're going to take the two values that you got, and before you decide that you're done with this question, you're going to plug back into the original absolute value equation and make sure that both of them work and that you've got good solutions. So let's do that now. Just a reminder, when we check in the original absolute value equation, which is the one that was given to us in the question. And both of these actually do work. So we're going to have a solution set that has both numbers. And there's our solution set, negative 21 and negative 3. Let's see if we can circle this one so it stands out from our work. Now let's take a look at 13b. In 13b, we notice that it's not in the form that we need, so the first thing that we are going to do is get rid of that 8. So we subtract 8 from both sides, and we end up with the absolute value of 3x minus 2 is equal to -7. And hopefully you recognize that this is not possible because we can't have a negative value come out of an absolute value expression. So what that means is on this one we have no solution, and that is our final answer for this question. We're going to move on to number 14 next. So we want to determine the equation of the line in the diagram. This is another one that you probably feel pretty comfortable with. We know that we can write the equation of a line in slope-intercept form, and our y-intercept is, we can already see, it's the number where our line intersects with the y-axis, and so our b is equal to -3. Now when it comes to our slope, that is going to be change in y over change in x. So we're going to look for how much we go up and to the right as we read the graph from left to right. So here's 1, 2, 3. So the change in y is 3 over the change in x, 1, 2. And that means that we've got everything that we need to write our equation. Y is equal to 3/2 x minus 3. And that's our final answer for that question. Let's take a look at 15 and 16 now. For number 15, we need to take each piece part individually. And the first part of it, we can see that we have a squared raised to the 5th power. Anytime we raise a power to a power, we multiply the exponents. So this is going to be a to the 10th. To that, we're going to multiply whatever the result of b cubed to the 0 power is. And if you remember, anything raised to the 0 power is going to end up being 1. Last of all, we have c to the 4th, and nothing magical or curious is being done to that, so that's going to stay as c to the 4th. When we write our final answer, we don't need to include that 1, so we can rewrite this as a to the 10th times c to the 4th, and that can be our final answer for this question. For number 16, what we want to be able to do is FOIL. And if you remember foiling, we are going to do first with first, outside with outside, inside with inside, and last with last. So I want you to pause the video here, work it all out, and come up with your final answer. Turn the video back on so you can check your work in just a second. Okay, here we can see color-coded the FOIL for FOIL and the final answer. So check your work. If you have an error, again, see if you can find it. Chances are you'll be able to figure it out yourself, but if not, bring it to school and we can talk about it. Last of all right, here we are on page 5, the last page of our algebra review, and we see that we have a quadratic trinomial to factor. And you may remember that with a quadratic trinomial, we have 3 terms. That's what trinomial means, and quadratic means the highest degree or highest power we see is a 2. So we typically write the generic form like this, ax squared plus bx plus c, and when we create our t-chart, it's a times c, so it needs to multiply to a times c, and it needs to add to b. So in this case, a times c is 3, and b is -4. So when we add the two numbers together, we need to get -4. So Let's try this out. We want two numbers that multiply to positive 3, but add to negative 4. So we can only get two numbers to multiply to positive 3 if they're both negative or both positive. We can get two numbers to add to a negative number if the larger one is negative or if they're both negative. So in this case, we know that in order to end up with positive 3, we needed to multiply negative 1 and negative 3. When we add those together, we get negative 4. So we're going to put these into our factored form. So x minus 1 times x minus 3. And this is our final factored form of number 17. Let's move on to number 18 now. You can see that we have a square root of 5x plus 14 equals 7. And in a case like this one, what we need to do to isolate x is square both sides. On the left-hand side, when we square both sides, we end up with 5x plus 14 because the square cancels out the square root. Now, this does not happen if we have two radicals that we're adding to each other, but in this case, we only have one square root, one radical, so we end up with 5x plus 14 is equal to 7 squared, which is 49. And then we continue solving the way that we normally would any other algebraic equation, and we end up with 5x is equal to 35. We can divide both sides by 5, and our final result is going to be x is equal to 7. And at this point, we are ready to move on to number 19, which is definitely going to take us a little bit longer. So with number 19, you can see that we have what we call a system of equations, which means we have two equations in two variables. And those, in this case, they are both linear equations, meaning they're in x and y, no squared variables here. So what we want to do is find the place or the point where these two lines intersect. If you remember, we have two different ways that are algebraic in nature. We can solve by elimination or we can solve using substitution. Sometimes we can solve by graphing, but that's not always going to be a sure thing because our eyes are imperfect. And that means that if it doesn't fall right on the corner of an exact value in the x direction and the y direction, our eye may see something that is not exactly right. And so we're going to drop back and solve using elimination and substitution. What I'd like for you to do is pause the video now so you can try to do that by yourself. And when you've gotten to a good stopping point, turn the video back on to check your work. I'm actually going to show both solving through elimination and substitution so you can see how both work. And depending on which one you chose, you should still get the same answer either way. You should still get the same exact answer. Turn off the video now and we'll see you back in just a minute so you can check the value of x and the value of y. Okay, so we can see here both the solution using elimination and using substitution. Either way, you're going to find probably the value of x first, and then you're going to plug into either one of the equations to find the value of y. So in the end, your answer is going to be an ordered pair, and your x comes first, of course, so negative 27 over 26. And then your y coordinate is negative 192 over 13. And that is our final problem in this algebra review. Well done. Once again, if you have any questions, remember bring them to class and or extra help.